In the past section, we used the ideal gas law to solve for an unknown property of a gas. In our examples, we assumed a pure gas. But the ideal gas law works for pure gases and gas mixtures. In a gas mixture, the gases are in the same container, so the volume is the same for each, and they would be at the same temperature. However, the pressure each gas exerts depends on the number of moles of each gas. Each gas obeys the ideal gas law, so if there were two gases, we can write an equation for gas number 1, and we can write an equation for gas number 2. The relationship holds for the total gas sample as well. Since the total number of moles of gas is simply the sum of the two, the total pressure is the sum of the two. The two individual pressures are called the partial pressures of the two gases. There are two types of problems that we can treat with the concept of partial pressures. First, if we know the amounts of the two gases present, we can predict the pressure of the gas mixture. Notice in this question that we are given the number of moles of N2 and the number of moles of O2 present. Of course, they're in the same container with a known volume and temperature. For the total pressure inside the flask, we'll use the ideal gas law for the total sample. The total number of moles of gas is 0.550 moles. Rearranging the ideal gas law for pressure and then plugging in the numbers, we find that the pressure inside the flask is 1.35 atmospheres. By the way, notice the temperature in the question was in degrees C, but we used the Kelvin value when plugging into the equation. Our strategy is almost identical to a normal ideal gas law problem, except that we had to add together the two moles first. A second type of problem is that we have information on the amount of one gas, but we're seeking information on the amount of the other. Here we have a flask with a known volume, total pressure, and a temperature. Using those values in the ideal gas law can lead us to the total number of moles of gas in the flask. We rearrange the ideal gas law for moles and then plug in the numbers. Calculation gives us 0.477 moles total. We haven't answered the question yet because we're trying to find the number of moles of dioxygen. But the total moles equals the sum of the two, so the number of moles of dioxygen is 0.477 minus 0.100, which gives 0.377 moles of dioxygen.